Picking up where we left off, 15b in the problems in the book. First of all, when you do a problem like this, do not get confused between the times when you use your exponent rules and the times where you just divide like you normally would. With 25 divided by 5, you just divide like you normally would. 25 divided by 5, you get 5. Or you could say 25 divided by 5 equals 1, 5 divided by 5 equals 1. Oh, did I say that wrong? 25 divided by 5 is 5, and 5 divided by 5 is 1. So we get 5 over 1, and then we take x to the third and x, and we say, when the bases are the same and you have a fraction, subtraction better be your action. So I take 5, and then I write in the numerator 3 minus 1. Because the result of the subtraction problem always goes in the numerator. 3 minus 1, we get 2. And 5x squared over 1 equals 5x squared. 15b, again, 30 divided by 6 is going to give us 5. Because 6 goes into 30 5 times, 6 goes into 6 1 time. So we have a 5 in the numerator, and I don't even have to write the 1 in the denominator, it's not necessary. Then I look at where the bases are the same. So x to the third over x, the result is going to go in the numerator. I subtract 1 from 3. And then I'm going to do the y in the next phase. So 3 minus 1, we get 2, so it's 5x squared. And then let's go ahead and take y to the second divided by negative y to the first, sorry. So 2 minus 1 is what we write for the exponent. Because when the base is the same and you have a fraction, subtraction better be your action. In the denominator, we're left with the hidden 1. So we get 5x squared y to the first over 1. And anything over 1 is just itself. So we get 5x squared over y as our final answer. The next problem, here we only have variables. So a to the third over a. The result goes in the numerator. In this case, I'm not going to write this over 1. It's not really necessary. So 3 minus 1, we get 2. 4 minus 4 equals 0. 4 minus 4, you get 0. Anything to the 0th power equals 1, so we have to use 2 rules for this. And the final result is a squared. Number 16, 4.5 to the negative second. Whether this base is a variable or a number, we need to get rid of the negative exponent. Negative exponents leave a scar, so we knock it over the fraction bar. So here's my fraction bar. The entire thing needs to go over it, and the only part that changes is the sign of the exponent. The sign goes from a negative to a positive. And in the numerator, we have a hidden 1, so we have 1 over 4.5 squared. If you take 4.5 and you square it, you get 20.25. But let's keep going. Right, power to a group you distribute. So we take the negative 1 to both the 7 and to the x. Then I'm going to flip both of these over the fraction bar. And what will be left in the numerator is a hidden 1. In the denominator, I get 7 to the first power, x to the first power, because when you flip something over the fraction bar, the sign of the exponent changes. So we get 1 over 7x is our result. 16c, power to a group you distribute to both the numerator and the denominator. So we get 2 to the negative first over 5 to the negative first. I'm going to move the 5 to the negative first over the fraction bar, and I'm going to get 5 to the first. The sign changed on the exponent. Then I'm going to take 2 to the negative first and flip it over the fraction bar. So it was in the numerator. Now it's in the denominator. I flipped it over the fraction bar. And now the sign of the exponent changed to a positive 1. So I get 5 over 2 as my result. 16d. Power to a group you distribute to the entire numerator and the entire denominator. And then negative exponents leave a scar, so you knock them over that fraction bar. When you knock something over the fraction bar, the sign of the exponent changes. This went from the denominator up to the numerator, and the sign changed from a -4 to a +4. This piece went from the numerator to the denominator, and the sign of the exponent changed from -4 to 4. So we get 5 to the 4th power over 1. And 5 to the 4th power is equivalent to 625. So the result is 625. 16e, this is the only piece that needs to change. We're going to flip it over the fraction bar, and we get 5 over x to the 3rd. When you flip it over the fraction bar, the sign of the exponent changes. Power to a group you distribute to both the numerator and the denominator. So we get 2 squared over 5 squared. So that's 4 over 25. And I think that the directions here say to change it from a negative to a positive. So let's look at this again. For those involving positive exponents, write an equivalent form using negative exponents. So instead, what they'd like us to do here, and I should have read the directions, is they want us to flip this over the fraction bar. 5 to the second becomes 5 to the -2nd. And then when you flip 2 squared over the fraction bar, it becomes 2 to the -2nd. So that's really what we should have done in the first place. Again, when you flip something over the fraction bar, the base and the exponent get flipped over the fraction bar. The only thing that changes is the sign of on the exponent. Originally it was a +2, now it's a -2. Up here, originally +2 becomes a -2. Letter G, power to a group you distribute. So 4 to the -2nd, a to the -2nd, x to the -2nd. And with each of these, if you wanted, you could put x to the first to the -2nd, but then that creates another step for you. You have to do power to a power you multiply and get x to the -2nd. Don't really care how you complete that part. But remember that we're really taking the -2 and multiplying it by 1 on each of these. Negative exponents leave a scar, so you knock them over the fraction bar. So this gets knocked over the fraction bar. This gets knocked over the fraction bar. This gets knocked over the fraction bar. So that's 4 squared, a squared, x squared. And then what is left behind up here in the numerator? A 1. So in the denominator we have 4 squared, a squared, x squared. 4 squared is 16, so we write 1 over 16, a squared, x squared, and that's our final answer. H, 5 over t to the 3rd, it said if it involves positive exponents, you want to flip it over the fraction bar. So I'm going to flip this over the fraction bar, so it's t to the -3rd. Now technically we could say that the 5 also has a positive exponent, so that would mean that we also need to flip this over the fraction bar. So we get t to the -3rd over 5 to the -1st. Okay, and that's all of the examples. So that'll be the end of this video. I hope you're understanding better how to use the second set of exponent rules.